All right, we're going to get started with our next speaker. Mr. John Pignata is a solution architect extraordinaire, and he's going to talk to us about how to save money. That's one of the most important pieces when starting a startup, is keeping your burn rate low. So John has tons of awesome advice on what to watch for, what to try and avoid, and how to keep your bill low. Cool. Take it away.
Hey, everyone. So, our terms, anything from companies with 1 or 2 people kind of working on an idea, all the way up to companies that maybe have multiple rounds of funding, through a venture capital firm or even in the private equity space. And this talk is really, it's geared toward actionable advice, like things you could do tomorrow in your AWS account to pay AWS less money. So I'm hoping you can take away at least 1 or 2 things that may be applicable to what you're building and what you're doing. If not, just take away the fact that there are folks here on the payroll of AWS, and our focus is to save you money. Like, we literally want you to pay us less, because if you pay us less, one, if you're a startup, that's going to go right into your runway, right? So it's like free funding. You're going to be able to use that money to spend it on things that actually matter, like engineers to implement what you're building, maybe customer acquisition, like things that are more important than like servers running in some data center somewhere. And 2, like we want you to make the most, the best use of all of the knobs and levers that we have. Now, frankly, there are a lot of knobs and levers, right? If you log into like the EC2, if you look at the EC2 pricing page, you'll notice there's a ton of different ways to acquire compute capacity, for example. But we want to help guide you through that. So if you take nothing else away from this talk, take an item to call your account rep tomorrow and say, look, account rep, figure out, like, here's my bill, how do I save money? Or come here to the loft. There's always someone standing at the architect booth who, from my team, or support, that can help you dive into your bill and give you actionable recommendations to lower your spend. Cool. And there's not many slides, so feel free to ask questions, keep it conversational. Just let me know what I can answer for you. So lower costs with the AWS cloud. So when we talk to customers, there's a ton of reasons why customers are moving to AWS or starting net new applications on AWS. Generally it's about agility. The idea that you're no longer blocked by internal procurement processes or teams. You could just spin up resources as you need them and experiment. And if an experiment fails, you can just get rid of those resources without any risk, right? Pretty obvious. That's the whole point of the cloud. There's a lot of pricing model choices to find the right way to acquire resources for your particular use case. So AWS in general, if you look at pricing on AWS, there's a few dimensions of pricing, right? We bill on compute, storage, networking, data transfer. But within all of these models, there's a few ways to save money automatically. One, there are incentives for volume, right? So as you use more, the per unit fee drops, right? So for example, with S3, it's something like with standard storage, the first X amount of terabytes is like 2 cents a gigabyte, and then it drops down from there, and it continues dropping. So lower costs on on-premises, this is kind of obvious, right? So in the long ago, when you were starting a business, the first thing you would do, one of the first things you would have to do is acquire the most expensive real estate ever in a data center, rack and stack some servers that you would buy at great expense from some hardware manufacturer, get them wired up and configured for power and ping, and then you could actually deploy your application. With services like AWS, a lot of that capital expenditure goes out the window, right? Even if you're virtualized, there's still capital expenditure that you can utilize those resources more efficiently, but you're still purchasing those resources out of pocket. With AWS, it's all OpEx and it's all usage-based. And you can start with every service on a utilization basis. Yeah, so capital expenditures, meaning something you purchase physically that you buy and own, versus operating expenditures, which is paying for services, for example. And the slides, they're going to mail out the slides, so you'll have a copy of this too. AWS's pricing philosophy. So Amazon itself is known for trying to lower prices as much as possible to take economies of scale and take what we were able to deliver and deliver it to customers at a lower price. Why customers like saving money. and Amazon, as a customer-obsessed company, wants to give customers what they want, which is lower prices. This is super outdated. It's not 62 price reductions. I think it's 66. So if you look at AWS's history throughout the last 10 plus years, dropped prices largely in the absence of any marketplace pressure to do so, just simply because, one, as we grow our customer base, there are economies of scale to that, right? We have millions and millions of active customers a month using our services. We're able to kind of pool all those customers together and deliver services at lower cost. Two, we are, internally, every team is incentivized to wring cost out of their own cost structure, meaning teams have goals to do things like automate and reduce the amount of toil and work and labor that comes into operating these services, and we pass those savings off to customers. So we've done it a bunch of times. We continue to do it. We'll continue to do it in the future. So cost optimization tips and tricks. This is the meat of it. So we're going to go through, I don't know, I think it's like 10 different ways that you could potentially save money with AWS. Number one, so this is regarding our Elastic Compute Cloud, so EC2, choosing the right instance type. So often when startups start their journey, build an application, put it in the cloud, they don't have any users, they don't have any traffic, there's nothing to kind of guide these teams on what they should be provisioning. So often teams will just provision large-sized amounts of compute in order to have it in case they have a large glut of traffic. So to start with, the first thing we try to do when we look at a customer's account that's trying to reduce cost is to figure out, are the instances that are used in that account the right size? So if you're, one of the things we'll do is pull up CloudWatch metrics. So if you look at CloudWatch metrics, most services dump metrics into CloudWatch. You can use CloudWatch metrics to get a sense for how utilized your instances are. So for example, you can pull up a graph of CPU utilization and see, okay, so of my web server fleet or a single web server, what percentage of that web server is actually utilized on a CPU basis? Is it 80% most of the time on average, or is it 2%? If it's 2%, it's very possible that you're oversized and you can scale that instance down. So you can start with things like memory and CPU and scale appropriately. Other tools that we have to help you, Armando mentioned Trusted Advisor. Trusted Advisor is essentially a console that tries to give recommendations to customers based upon the data that's in your account. So for example, across the pillars of security, optimization, reliability, and cost optimization. So you can log into Trusted Advisor into the AWS console, click on Trusted Advisor, and you'll see, like one of the first items you'll see is you have the potential to save X thousands of dollars, and here are the recommendations to do that. So that's a tool that you can use today to figure out, am I right-sized with the instances I'm running? Both CloudWatch metrics, which gives you the raw data, and Trusted Advisor. And then deploying and scaling. So instead of having one large instance, for many reasons, cost being one dimension, it's typically better to have multiple instances and multiple availability zones. So way back when, for reliability, if you were building in a data center in the late 90s, for example, you were kind of lucky if you had one server at one side of the room and one server on the other side of the room. That was kind of high availability. Right, with AWS, you can easily deploy with a couple of API calls servers to multiple physical buildings. Right? So an availability zone is a physical, discrete building that's located some miles away from the other availability zones, but connected to each other through low latency links. So you could very easily deploy your application across multiple availability zones and both improve your reliability and potentially reduce your cost, assuming you're able to size those instances down. That all make sense? Okay, cool. Use auto-scaling. So one of the sort of revolutions of cloud computing is the idea that you no longer have to provision the amount of capacity you need to handle your peak load, right? So back in the old days, you would have to buy 10 servers with the understanding that in November, when shopping season ramped up, you're going to need those 10 servers to fulfill your demand because it takes 8 to 10 weeks to get a new server. With AWS and other, with cloud computing in general, you could instead use some of these tools like auto-scaling to match the amount of resources you have provisioned to your actual customer demand, right? So the way auto-scaling works is it looks at metrics, like metrics in CloudWatch, like I mentioned before, and it will scale the number of servers you have in and out based upon what's actually going on with those servers. So for example, you can tell auto-scaling, I want a minimum of 2 servers at any given time across 2 availability zones, and at most I want 10, just as a cost control measure. You can cap it. And throughout the day, watch this number. If my server farm ever goes above 60% utilization on CPU, start scaling out, add servers. Once that traffic dies down and customer demand dies down and that CPU load starts to drop, well then start scaling back in, right? So auto-scaling is kind of a set it and forget it way to elastically scale the amount of compute resources you have provisioned without manually doing it, right? You don't have to manually scale up and down, turn a crank. You can instead have auto-scaling handle that for you. Is anyone using auto-scaling today? I'm just curious. Okay, cool. All right, so old hat. So auto-scaling group. Auto-scaling also integrates with some of the pricing features of EC2, like spot instances, which we'll talk about later. But there's ways to leverage auto-scaling both as a cost control to take advantage of the elasticity of AWS, and also as a reliability measure to ensure that if your 2 servers are in an availability zone that has a service disruption, auto-scaling will automatically add 2 more servers in the other availability zones to compensate. So here's an example of utilization with auto-scaling. So here's like a traffic pattern. This is like a 24-hour period. For some reason, we have a large glut of traffic throughout the workday, which is pretty common for like SaaS applications. Oddly, in the evening, we have our zenith there for some reason, but this is our traffic pattern, so this is what we need to scale to. So we want to make sure that the amount of instances we have deployed could handle this load within the time period that load exists. So in the old days, you would probably like draw a line somewhere above, like maybe 15% above that zenith, and you would say, okay, we're going to provision to this amount so we could handle our daily load. Auto-scaling, you don't have to do that, right? So here's an example with M4 large instances, which are something like 10 cents an hour. Is that right? $4 a day? Anyway, so it costs some amount of money. I think this is wrong. But in any event, you have a number of instances for some amount of money. This is a pretty large size instance, a couple of virtual cores. That's costing you some amount of money per day. And you're scaling. Auto-scaling is adding new instances as your traffic increases. And importantly, it scales it down, scales it back up, and then scales it down. But you could, again, getting back to right sizing, there's a potential to use more smaller instances. So here's an example, the same cost optimization, the same kind of like cost dynamics and the same traffic curve where we replace the M4 larges with T2 mediums. And we need more of them, right, because they're less beefy machines. But we have 70 of them. And we tell auto-scaling, OK, add and remove them as need be. Just doing this, just using a more appropriate instance size, gets us a quarter savings. So we're able to save 26% on what we had here with the M4 larges. So a couple things. I mean, this ties in 1 and 3. Auto-scaling will add and remove capacity for you automatically and make sure that you're right-sizing your instances to achieve the maximal savings possible. Turn off unused instances. OK, so another thing we see often are, a customer will come and say, I'm trying to save money. We'll look for instances that have no usage or have names like dev old or something like that. Just stop them, right? So you're paying on demand per minute or second or hour, depending upon the license for that instance. If you're not using it, just simply stop it, and EC2 will stop billing you. It's as simple as that. If you use some of the newer services, we're going to talk in the next talk about infrastructure as code. But if your instances are being created by services like CloudFormation, which is our infrastructure as code service, maybe you're using a third-party partner tool like HashiCorp's Terraform, maybe you're using Ansible or some other configuration management package. If you're treating your infrastructure as code and it's easily reproducible, then tearing down a server shouldn't be a big decision, right? It should be a very easy decision to say, OK, I no longer need that server. I'm going to stop it so we're not paying for it. And when I need it later, I'm going to execute that CloudFormation template and get that server back, right? So you don't want that to be a big decision. And you want to make sure that you don't just have servers sitting around waiting for work. That's just costing you money for no reason. And there are tools and techniques to help you here. I mentioned DevOps tools. Things like containerization help a lot, where instead of having a single instance dedicated to a single application, now you can utilize more of that instance for multiple applications, because containers will capture the environment for single applications in a self-contained image. Usage tracking, using CloudWatch metrics, just keeping an eye on what instances and what resources you have in your account from time to time is super helpful. Okay, 4, use reserved instances. So the next couple are about paying sticker price. So for EC2 specifically, one of the billing dimensions is compute time, right? So depending upon the license you use, if you're using Linux, you're charged by the second. If you're using some versions of Linux or Windows, it's by the hour. But you're essentially you're charged a single fee for that by the hour. Reserved instance allows you to make a reservation for a given capacity and for a given period of time. And in exchange for that, AWS will provide a lower rate for that instance. So for example, if you have a database server, maybe you're running MongoDB, and you're running that on EC2, you know that MongoDB production database server is going to be running 24/7. You want to pay the least amount that you can for that database server. You want to ensure that it's on all of the time. Reserved instances allow you to purchase that block of compute for a different term. It's 1 year or 3 years with different payment models within that. So there's a lot of flexibility within reserved instances to either, there are no upfront models where you just say, look, I'm going to use this for a year. Give me a lower rate by the hour or by the second. Or I'm going to use this for 3 years, and I'm willing to give you all the money up front, right? And of course, that nets out to be a lower amount of money. But essentially, what to take away from this is if you have instances running 24/7 and you know they're not going away, don't pay sticker price for those. Use the reserved instance model to pay less for that capacity. Make sense? Excuse me? Yeah, there are all upfront models, but there are models where there's no upfront. So there are models where instead you just make the commitment for a year, right? And you don't pay anything up front, but you do get a reduced monthly rate for that instance. Cool. So here's an example of RI pricing. So if you go onto the EC2 pricing page, you're going to see a super long page with all this stuff. So an example, the on-demand rate is about 2.5 pennies an hour. If you opt for the no upfront reservation model, you get a 20% savings off the bat. So you pay more like 2 cents, give or take. And you'll see that the number goes down as you either commit for longer periods of time or provide more of the purchase price up front. Okay? And reservations for capacity go beyond just EC2, right? So EC2 is the canonical example of where to reserve capacity. But if you're using things like Amazon Elasticache or Redshift or RDS, these also have models where you can reserve nodes. And likewise, DynamoDB, Amazon DynamoDB will allow you to reserve capacity units. So you can say, look, my DynamoDB table auto-scales for me throughout the day, but I know my base utilization is whatever, X units read and write. You can reserve those for a given period of time for a reduced fee. Okay, use spot instances. Anyone using spot instances today? Okay, cool. So since reInvent last year, this is my latest bugaboo with customers. I like to approach cost optimization as a game because there's an easy way to keep score, right? So the first thing I look for when I'm in a customer's account is how many on-demand instances do they have and how many of them can we kill. So spot instances allow you to use unused EC2 capacity at a huge discount, up to 90%, it says 92% there. But basically, for every instance you're running, you can get 10 for that hourly price, okay? So what's the catch? The catch is that there's a potential for those instances to be interrupted. So the spot market is unused capacity. If the capacity changes, right, the capacity demands change, it's possible your spot instances can be reaped or terminated by EC2, right? You'll get a 2-minute warning that you could monitor, and you have 2 minutes to kind of get the heck out of Dodge and get your workload off. That sounds scary. It's actually not that scary. There are lots and lots of different applications where that's totally fine, right? Think about a web application. If you're running a web application, a normal transaction, whatever your 99th percentile response time is, like that's kind of what you have to plan for, right? That number is going to be like hundreds of milliseconds at worst. It's not going to be minutes. So if you have a web application running on a Spot instance, or more likely a fleet of Spot instances, and that web application gets interrupted by Spot, that's fine. It will, you can drain the load balancer, drain what's on there in that 2-minute period, and then, that capacity goes away. Spot, through Spot Fleet, which is a way to manage a group of Spot instances, will spin up a new instance, and your application can restart. So there are there are AWS services that really shine with Spot. So for example, the Amazon Elastic Container Service, ECS. If you ever spin up a cluster of ECS instances, ECS is a way to run Docker containers in production. If you ever spin that up, there's an option in the console to say use Spot. If you select that, it will essentially spin up a group of instances on Spot for 90% off the sticker price. And anytime that Spot instance is interrupted, it has code in it that will automatically monitor that. It'll tell ECS, hey, I'm about to go bye-bye, move my processes somewhere else, and ECS will handle it for you. All right, so at reInvent last year, a few things changed with Spot. A lot of really cool changes. So Spot used to be a pretty volatile market, right? You can I don't have the graph here, but if you look at a graph like pre-November, you'll see that different instances at different availability zones often spiked up and down, right? Since reInvent, they've smoothed out pricing changes. So pricing changes now happen over weeks period of time. So the market is really stable. Another thing that the Spot team changed is that you could spin up Spot instances just by running an instance. So when you run instances either through the CLI or an API or through the console, you could say use the Spot market. And it'll just spin up the same instance, the same API call that you used before, but at a fraction of the cost. When I say the fraction, it's like really striking. I mean, if you look at, I think an M5 large in US East 2 or Ohio region costs about 20 cents an hour. On Spot today, it's less than 2 cents. Right? So you could have 10 of those for one on-demand price. There's literally no reason not to use it. And the way to use it is to build big diversified pools of Spot instances across all different kinds of instance types across every availability zone. Okay, so Spot is awesome. I can't say it enough. I think when I was a customer, I was a little intimidated by Spot because there was some marketplace dynamics to it, and you had to bid. All of that's gone. All you really have to do is say, I want to save money, and EC2 will charge you less. Make sense? So anyone running an on-demand instance for a web application today? Is anyone in this room? Like tomorrow, just spin up a Spot instance, right? Move to a Spot cluster. No reason not to. You'll save 90%. So using Spot for HPC workloads. There's a couple really cool HPC stories with Spot. There's one out of Clemson a couple of months ago. So Clemson University did a large-scale NLP project across like 1.1 virtual cores, right? So they were able to, 1.1 million virtual cores. They were able to get that capacity fully on Spot, right? And they didn't have to spin it up on demand. They were able to use Spot. They were able to do it at a fraction of the cost that they could have done it elsewhere. Another thing that's important to keep in mind with Spot, and this is something that I don't think we tout enough internally, 95% of Spot instances are terminated by customers. So that means only 5% of instances, 1 out of 20, get reaped by the service. So it's actually the minority event where Spot instances get reaped. So HPC is a great use case for Spot, data processing, machine learning model training, web applications, any application that's interruptible, job processors, that kind of thing. Okay, does that all make sense so far? Any questions? Okay, cool. Make use of appropriate storage classes. So let's be honest, there's a ton of ways to store data on AWS, right? There's a ton of different kinds of storage services. There's block storage, there's object storage. Within that object storage, there are many different kinds of storage tiers. So you have some decisions to make. But remember that that's your leverage, that's your lever to save money on the data you're storing. So knowing the data knowing the dynamics of the data you're storing, how much data it is, how it's accessed, how often, its durability requirements, its temperature, right? How hot is it? How often is it going to get accessed? Allows you to make some of these decisions. So for example, Amazon S3 provides a couple of different storage tiers. One is one is the standard tier. That's where you give Amazon S3 an object, a file. It will distribute that file across at least 3 facilities. It's designed to deliver 11 nines of durability, right? So that's like, if you have 10,000 files over 100 million years, something like that, you'll lose 1 file maybe. So extremely durable in design and pretty cheap, right? A couple cents a gigabyte. And S3 is kind of becoming the lingua franca of object storage. It's a very well-supported API that's supported in lots of application languages and in a lot of client-side tools. Within S3, there are different storage classes below standard, right? There's an infrequent access storage class where you tell S3, I want you to store this data. Maybe it's a database backup. Maybe it's logs that I don't think I'll ever need but may need in an emergency. You can store it there and pay 50% less than you would pay on standard, right? Just by basically indicating that you want to use infrequent access on storage. There's another storage tier called infrequent access single zone, where you say, not only am I not going to access this data, but you know what, that whole 3 facilities thing, don't worry about it. Store it in one place. If I lose that data, that's a bummer, but I could regenerate it. No big deal. And you'll be charged less for that. There's Amazon Glacier, which is cold, cold, cold storage. So the idea with Glacier is, think of it as like what you used to put on tape, but in the cloud, right? So I have some data, maybe a database backup, maybe something like that. I want to store it in AWS, but I don't think I'm ever going to need it. And if I need it, I don't need it very quickly. I could wait minutes or hours to get that data back. Amazon Glacier is perfect for that. And it's great for compliance scenarios as well. So if you're if you're financial compliance requirements and you need to store data in the cloud, Glacier is a great way to do that because it has built-in things like Vault Lock that allow you to ensure that those data don't move for a given period of time, 7 years. So the point of this is, so that was a lot of detail. The point of this is there are storage tiers, and you can choose from these storage tiers to pick the exact right place for your data for the least amount of money possible. Okay? This slide is out of date. So this reduced redundancy storage, don't use that. That doesn't exist anymore. In fact, AWS has been very good about not deprecating services. There are services like SimpleDB, which most customers probably don't even know about, which was an old database service. Still up, still supported, still has lots of big customers today. Reduced redundancy was a storage class that has been deprecated. It's still available, but it's more expensive than standard, so no point in using it. Excuse me? EBS is Elastic Block Store, so that's on the block storage side. So EBS allows you to attach a volume to an EC2 instance, and that volume becomes persistent. So if you have data that you're storing, like let's say a database server, you may attach an EBS volume to store its data. And that EBS volume is like network attached storage, a single volume. There's also EFS, the Elastic File Storage, which is essentially like a shared NFS mount across multiple instances. So, and those have their own performance dynamics. They have their own cost dynamics. So it's just about picking the right, cheapest, most efficient, most performant store for your workload. Yes, ma'am?
Sorry, I'm not sure how to speak in it.
No, go for it.
With those spot instances or just cost savings, is there any way to talk about lambdas and how
Totally. Yeah, that's coming up. The question was, could we talk about lambdas in lieu of cost savings? Yeah, and that's great. The best server is no server, right? So Lambda is something we're very excited about, and frankly, customers are excited about for that reason, for cost. Offload from your architecture. Okay, so the less you have to do directly, the less undifferentiated heavy lifting you have to do, the better. So things like, I think if you look at the way developers used the cloud, 10 years ago, there was lots of building our own web layers, there, our own load balancing layers. There was a lot of, kind of like building our own mini kind of CDNs, right? With things like CloudFront, you can get that functionality kind of out of the box, right? For every website with static content, if you're serving that static content through your main web server that has your business logic, well, every moment that it's throwing bits over the wire of an image is a moment that it's not spending doing things that are proprietary to your business, like running your business logic, servicing your API requests. So things like Amazon S3 which in addition to being an object store, also acts as a static web host with Amazon CloudFront, kind of offload that, allow you to scale your web server fleet more efficiently, right? Because it's no longer doing the task of just shoveling data over the wire, and allows you to offload the maintenance and monitoring of the static web serving system to AWS. So use managed services where possible. Offload things that your web servers don't have to do, that another service could do more efficiently and more cheaply. Take advantage of that. Yeah, and use services, don't reinvent the wheel. So AWS today, I think, is something like 125 different services. You know, what downside of that is sometimes it's hard to keep up, right? So lean on us to help you solve the problems you're trying to solve with the services that are in your toolbox here. This can seem pretty overwhelming at first, and frankly, even after a while, it can seem a little bit overwhelming. That's why there are teams of folks here to help you navigate through it. And yeah, avoid undifferentiated lifting. So just like with S3, things like Amazon Relational Database Service, RDS, instead of managing your own MySQL server and spending time on things like figuring out how to do high availability, figuring out how to encrypt the volume, figuring out you know, database size, security patching, et cetera, you know, you can lean on Amazon RDS to solve a lot of those problems for you. ELB, you know, likewise. So a lot of these managed services are made to kind of dry up a single problem area across multiple customers into a single managed service that's hopefully that's, you know, cheaper to use and more efficient for your infrastructure. Okay, use consolidated billing. So consolidated billing helps in a couple of different ways. There are lots of customers and startups, even at the small scale, who have an account for development and an account for production. Consolidated billing allows you to have a global view of all these accounts. It also allows you to share RI discounts. So you can reserve instances in your master account, and those reservations rain down to your child accounts. So this is a small thing. It's much smaller than what we've talked about, but it really helps to kind of like uncover those hidden spends of, you know, there's a few $1,000s of spend each month here in this account that no one was looking at, that was just digging a credit card. Using consolidated billing helps unearth those. And sorry, one moment. And take advantage of AWS tools. So I mentioned CloudWatch, there's AWS Cost Explorer, AWS Trusted Advisor. These are services that are geared toward helping you save money. So Trusted Advisor especially is a service where when you log in, it'll tell you here's how much you can save and here are the steps you should take to save that money. On using services, so I just want to go back to that because there's not a lot left in the deck. So serverless, I don't know, any folks using Lambda today? You're probably using Lambda, yeah. Anyone else? Okay. So Lambda is a hosted compute service that allows you to run functions in the cloud without servers, right? So the entire kind of serverless thing is about giving you a platform where you can deploy your code, and that code could run in response to events. An event can be an API call from one of your customers. Maybe it's an object being created in one of the storage systems. Maybe it's a scheduled event that happens. The great thing about Lambda is you don't scale anything, right? So that auto-scaling stuff we were talking about before of, you know, how do I scale up and down? With Lambda, that happens automatically for you. You don't pay for idle, right? So even with this auto-scaling bit, there's a little waste here, right? So you see this little bit here? That's capacity that's really not being taken advantage of because the grain of scaling here is an entire instance. With Lambda, you're charged as functions execute in 100 millisecond blocks and by request. So you pay a fraction of a penny for when your code is running as opposed to paying a per second fee for an entire instance. So it gives you a really, does that all make sense? Okay, it really gives you a very granular way to scale. So the gateway drug to Lambda that I've seen with customers is the server, everyone has this server called like scheduler or cron or something like that that sits out in the corner and just waits for every 10 minutes to do something. With Lambda, you can take that code that's running in that server, put it in AWS Lambda, and tell Lambda, hey, I want you to run this every 10 minutes. Right? Now, instead of paying for that server to run, you're just going to pay Lambda for 100 millisecond execution blocks for when that code is actually running. So it's a really great way to save money. You know, a lot of this presentation is geared toward had to save money on EC2 instances and using RDS and all that. But there are even higher level managed services like Lambda, where you don't have to pay for idle, you don't have to worry about scaling, and you can just pay for what your code is actually doing, as opposed to paying for the entire resource out of the box. Does that make sense? You probably knew that, but was there anything specific you wanted to cover?
Yeah, I'm just like worried that integrating that versus integrating the container. So I want to automate so many different functions, but it's like, what do I really automate versus just using
Yeah. Yeah, so the question is like, when do you, let me make sure I got this right. When do I use AWS Lambda versus something like AWS Fargate or the container service? Yeah.
I'm not saying everything, I'm like, slow down and like really think about it.
Yeah. So, I mean, what I've noticed is it's kind of like caching and relational databases, right? It's usually, a lot of customers' infrastructures have both, right? So they'll move some things into Lambda where it makes sense, like that scheduler. They'll move that into Lambda. Or they'll move a high request rate API endpoint into Lambda. And then, either slowly move their entire application into Lambda, which we're seeing quite a lot, or, have a portion of their application in containers and a portion on Lambda. It really depends.
It's like video processing and image processing for computer vision. So we're trying to move all of that with pure automation.
Yeah.
So we're not sure if we should just put it in a container and just build an environment just for that, or just let it automate from Lambda. So I'm just wondering, like, is there a cost saving better with the Lambda versus
Yeah, I mean, a couple things to keep in mind, right? So with AWS Lambda, there's a 5-minute execution timeout, right? So the ceiling is 5 minutes of execution, which means, customers either divvy up their workload across many Lambda functions, scatter the work out and then gather it, and then report on it, or they'll use a different kind of compute model where there's no 5-minute kind of limit, right? So we launched at reInvent something called AWS Fargate, which allows you to run Docker containers on AWS managed hardware. So you get a lot of those benefits of serverless, like not having to manage underlying instances. You're still paying for idle, right? Because you're charged for the container running. But it allows you to, it accommodates a wide range of compute tasks where Lambda may or may not work. Cool. Yes, sir. Yeah. Mm-hmm.
So it's like the more functions you execute, the more the cost you do, because as the function executes, you get a cost. So it's like you can execute a lot of functions,
Yeah.
and you can end more than just having a EC2 server.
Yeah.
Is that possible?
Sure, yeah. So the question was, or the comment was, because you're paying per function execution, are there use cases where AC2 might be a more appropriate compute platform for that because it'll be more cost effective? That was your question, essentially, right? Or comment? Yeah, the answer is yes, right? There's so many different kinds of workloads. There's millions and millions of different kinds of applications running on AWS, and that's why all these compute models exist together, because there's no one answer, right? There's a lot of different kinds of workloads, and a lot are suitable for Lambda. Some don't work, and things like AWS Fargate and ECS, things like EC2 and other compute models are there to kind of help out there. Yes, sir?
I use P3s with spot instances.
Okay.
The problem having is when I launch them, I don't get them instantly. I have to wait.
Yeah.
How do I determine when I get them? And then they also shut down very quickly.
Yeah.
How do I determine the start and stop time automatically?
Yeah, so the question was about P3 instances, which is our processing instance, which is essentially a GPU-enabled instance. This gentleman was using it with Spot and found it to be less than pleasurable because the availability was low, and once he did get instances, they were starting and stopping on him. With specialized instances, that's definitely possible. Let's talk after, because I want to know more, and we can kind of dig into it. But essentially, I mean, Spot, there's X amount of capacity in an AWS region, right? And there's tools like Spot Fleet, which help you build diversified fleets of EC2 instances to prevent that case. If you're going for a single instance type, it's going to be a lot harder, right? So you're already starting with a smaller base, and you only have a single kind of instance. So the marketplace dynamics will be a little tougher. But let's talk about the specifics.
But Spot also allocates to you. You don't just get to sign up. You have an allocation on demand for Spot. You have to get permissioning for the P3 and 17.2.
That's about the limits. Yes, yes. So there are limits in place. The limits are really there to protect customers, but there can be like a lag. You have to file a ticket. Sometimes it's a little bit of a bummer, but it's there to kind of protect you from like having a script that goes crazy and spins up 100 GPU instances and gives you a bad day at build time. Yeah. Let's talk after though. All right. Yes, sir.
Slightly more general comment.
Yeah.
Say you have something that's like hooked up with P3s and P2s, and would be a great use case for Lambda if you had that same GPU capability. Is there anything in the roadmap or any guess as to if that would ever
Yeah.
something AWS could provide?
Yeah, so something to keep in mind is that like literally, I mean, we say this all the time, but like 95% of what we build is just based upon like questions that customers ask us and conversations and like, hey, I need this to do my job. So you could expect that, that's not the first time I've heard that question. You could expect there's something on roadmap somewhere across different teams to support GPUs across all of our compute models. I don't have any specifics, of course, but I would encourage you to ping your account manager and tell him or her, hey, I need this, because that feedback will get to the service teams.
Last question.
Enforcer. All right, cool. Thanks, everyone. Let's stretch, and we'll be back here in half an hour. Thank you.
All right, so we have a break at this point, 15 minutes, and then we'll get started again.
15?
So definitely, if you have more questions for John, hit him up out at the Ask an Architect bar. Otherwise, he'll be back in the room in about 15 minutes for the next talk.